Okay. So good afternoon, everyone. I hope everyone is able to hear. Just a minute. Yeah. I hope everybody is able to hear properly. Yeah. Good afternoon. So welcome to the English revision through question. Because some time back we have done PYQs, and many students were requesting, okay, welcome Rohit, Manoj Kumar, Lucky, good, Manoj Kumar, okay, very good. So many students, those who are from South India and eastern parts of India, they were requesting us to speak in English, because that was for English batch. So we were speaking English, Hindi plus English. Now we have taken many initiative, and this one is the first one that we should do at least 10 to 15 questions in English, and much more initiatives will come from our side to get you ready for GATE 2024 and 25, and we have already English batches. So this is the second lecture. I will be covering material science and manufacturing processes, part 1, and we will be discussing very new questions, not PYQ, and I have made these questions. And there is another lecture of mine on 17th in English. Those questions will be different questions. So let us do these questions together and try to learn new fundamentals. And if you have any doubt, you please ask, because this lecture is live. So these are basically revision through questions for timing 4 to 6 p.m. This is the schedule. I hope everybody, because everybody is in the Telegram channel, so you will be having that schedule. And this is our team Drona, because every faculty is expert in his subject. So now I am going to start around 13 very beautiful questions. Out of these 13 questions, I have taken only 2 PYQs, because those PYQs are very good questions. Through those PYQs, I will teach you some fundamentals. Otherwise, out of 13, 11 questions are very beautiful questions. And with that help of those questions, we are going to learn many things. Okay? So let us begin. I will be covering 4 topics: material science, metal forming, metallurgy, and casting. And the remaining 4 topics our other faculty will take, Aditya Palji, and his schedule will be there in the schedule sheet. So I will be covering questions on the 4 topics. 13 very beautiful questions. So first question is, once again, you are welcome to write answer in the chat box, and if there is any question, that also you can write in the chat box. Okay, now I will be reading the chat box frequently. First question in the material science. So which one of the following is it's a MCQ, but quite possible it can be made MSQ, but it's a MCQ. Are true to produce ferrite and martensite dual phase structure. Dual phase steel. There is something called dual phase steel, DP steel. Okay. So which of the option is correct? Heating evap. See, here I am referring some lines. A1, A3, ACM. What are these lines all about? First of all, learn that. Because even in some GATE exam previously, around 15 years back, question used to be referred. Yeah, good evening, but I'm focusing on a question now. About these lines A1, A2, A3, A4, ACM. What are these lines all about? Let us first of all discuss about those lines. So if you see the iron carbon phase diagram. It is also called iron cementite phase diagram. So in the previous discussions, I already told you how to construct this diagram effortlessly. 725 degrees centigrade, and this is 1150 degrees centigrade, and it is like this. Effortlessly you can make this diagram. And alpha, gamma, delta, liquid, and Fe3C. Now what are these lines? A1, A2, A3, A4, ACM. First of all, let us study that. There is something called A0 also. See very carefully. Once again, if there is any question, let me know in the chat box. This line, 725 degrees centigrade line, this line is called A1 line. A1 line. These are the lines at which some transformation is taking place in the material. A0, A1, A2, A3, A4, and ACM. There are 6 lines. These are the lines at which some transformation is taking place in the material. So A1 line, it's a eutectoid temperature. Now there is something called A0 line also. Way below, it's a A0 line. And the A0 line, it appears at 210 degrees centigrade. Generally, most of the phase diagrams you see in the book, these lines will be there. So now, what transformation is taking place at 210 degrees centigrade? Can you tell me in the chat box? What transformation is taking place at 210 degrees centigrade? So first line A1, everybody knows it's a eutectoid decomposition, 725 degrees centigrade. Now there is something called A2. This line is A2, appears at 768 degrees centigrade. So at 768 degrees centigrade, iron converts from ferromagnetic to paramagnetic. At 768 degrees centigrade, iron converts from ferromagnetic to paramagnetic. Paramagnetics are partially grain boundaries decomposition. You know, it's a heavy material science, so you know, I think some people may not be able to guess. Okay, no problem. Ferromagnetics are, because I'm going to start material science now from tomorrow onwards, full course. So I will dive deep into the subject. Ferromagnetic materials are highly magnetic materials. Paramagnetic materials, very, you know, their magnetic properties are very less, mostly non-magnetic, but if you induce, you will be able to succeed little bit magnetism. Yeah, you are correct, right? And dimagnetic, they are completely non-magnetic. So 768 degrees centigrade, iron decomposes from ferromagnetic to paramagnetic. You know what is this in A0? Because 2 of my students, they tried, but they are not succeed. This is the temperature at which ferrite demagnetized, and this is the temperature at which cementite demagnetized. Below 210 degrees centigrade, cementite is magnetic, ferromagnetic, and above 210 degrees centigrade, it is non-magnetic. So tomorrow I'm going to tell you, very deep things. Tomorrow is only phase diagram. It's a 7 days course. Now, see, this line is called A3. This A3 line is also called upper critical temperature line. A0, A1, A2, A3, and this line is called ACM. Okay, na? ACM. This line is called ACM, and here it's a A4, where gamma completely converts into delta phase. Gamma completely converts into delta phase. Okay. So now comes to the question. Which one of the following are true to produce ferrite and martensiite DP steel dual phase structure? So to produce DP structure, dual phase structure, what exactly we do? We low carbon steel, we heat in this range. You know, in this range, there is alpha and gamma. We heat in this range. So because low carbon steel means less than 0.3% carbon is the low carbon steel. So what will happen? Mostly it is alpha, but little bit gamma will be there. Mostly it is alpha, but little bit gamma will be there. If you see the microstructure, and from this temperature, if we quench, gamma will be, the alpha will be as it is. Alpha in the entire microstructure, alpha will be as it is. But gamma will convert into martensiite. So, you know what will happen? There will be particles of martensiite. There will be particle of martensiite in the structure of alpha. Primarily it's alpha structure, but there are dots of martensiite. So when the dislocation moves, these martensiite particles creates obstacles in the movement of dislocation. So material becomes very strong. This material is called DP steel. This material is called DP steel, 12-phase steel. You know where this material is used? In the construction industries. In multi-story building, Burj Khalifa and bigger buildings, whatever steel they use, of course it's a TMT, thermomechanically treated, but the material is DP. So here, which one of the following is true to produce ferrite and martensiite dual phase steel? Heating above A1 line and below A3 line. That's what it is. Heating above A1 line but below A3 line. Below A3 line followed by furnace cooling. Heating above A3 line followed by quenching. A3 line above we will not heat. Heating above A1 line and below A3 line followed by quenching. Heating above A321 line, because they included everything, 3, 1, 2. And below ACM line, no, ACM line is not anywhere, na? ACM line, we are not considering anywhere. So, followed by quenching. So, answer should be C. Answer should be C. So, once again, it's a alpha and austenite. When we are quenching, there is no change in alpha, but austenite will convert into martensiite. Very small pocket of martensiite. For any ductile material, fracture will be by dislocation motion. So these small pockets of martensiite creates obstacles in the movement of dislocation. Strength in alpha itself is a very strong material, plus obstacles due to martensiite, small pockets. Material becomes very strong. DP steel. So with the help of this question, I have told you many side points about the iron carbon phase diagram. Is that okay? Yeah, you see answer. Acha, A2 line. A2 line, what is A2 line? A2 line is a horizontal line at 768 degrees centigrade. These lines, some kind of transformation happens. Below A2 line, ferrite is magnetic, and above A2 line, it's a horizontal line. Here, it's a horizontal line, A2 line. Above A2 line, ferrite is non-magnetic. Correct? I hope everybody is okay. I think Rohit is basically our constant companion from the crash course. 17th, again, I will be myself and Adit Palji, they will be discussing a lot of questions. New question, different than these questions, okay? So, this answer is C. Material science, very, very beautiful question. Very good, very good. This is the question number 2. This is the question number 2. Each question is a gem here. Please read the question because we have sufficient time. I have only 13 super 13 questions. Yeah. Please read the question. It's MSQ. It's MSQ. More than one options are correct. In a metal rolling operation as shown in the figure, so this is the deformation zone, and here is the neutral plane. This is the neutral plane. So from here, extruded product goes out like this. In a metal rolling operation as shown in the figure below, point C lies on the neutral plane. Okay, what is the neutral plane? Neutral plane is the plane. Neutral plane is the plane at which friction changes the direction, or the velocity of roll will be equal to the velocity of deforming material. Okay. In such scenarios, which of the following options are correct? V is velocity, sigma is stress, and W is the width. W is the width. Okay, Manoj Kumar Kumbhavat. Yeah. Rohit. Good, good, good. Velocity is very easy. Velocity is very easy. And I hope everybody will hit that. This is VB. And this is VA. Certainly after deformation, velocity will increase. That is a common sense, everybody knows. So A is the correct option. A is the correct option. Now, another thing you should remember, that it's a plane strain case. It's a plane strain case. What is the plane strain case? What is the plane strain case? In any metal forming operation, when the metal flow is restricted in one direction, it is plane strain case. It's a plane strain case. So in the unless and until it is given in the direction of width, there is no metal flow. In the direction of width, no metal flow. So W1 will be equal to W2. So delta W is 0. Delta W is 0. Okay, now comes to, certainly this cannot be correct answer. Okay, na? Because velocity we have already discussed, this answer cannot be correct. Now comes to stress. Now, at this point, stress will be more, or at this point, stress will be more. This is sigma B, and this is sigma A. If you see the friction hill, always at the exit side, stresses will be slightly more. In other words, I will tell you, while calculating the rolling load, we assume that neutral plane is exactly in the middle. That is the reason we do, na? F into L by 2 is equals to torque. This formula everybody mucks up. So torque L by 2. You know why we do L by 2? Because we assume that our neutral plane is exactly in the middle. But in the realistic case, it will never be in the middle. It will always be towards the exit. It will always be towards the exit. So if the neutral plane is shifted slightly toward the exit, this component of stresses will be more. Towards the exit, then this component of stresses will be more. And because when you draw the friction hill, let us draw it again so that some of you, quite possible, they may not have studied this thing before. Okay, incoming material, outgoing material. So if you draw the friction hill, let us say this is the neutral plane. Friction hill will be like this. So more the neutral plane is shifted towards the exit, more will be the component of stress on that element. This is the friction hill. So here sigma A will be greater than sigma B. Answer A, C, D. 3 options are correct. A, C, D, 3 options are correct. Relatively, I have chosen some tough question for this session. Some tough question, because we say, na, shoot the rhinoceros. If you go to shoot a mouse, and if you kill a mouse, what is the fun? Go to shoot the tiger, let us say. And if you are not able to shoot tiger, at least something will be shot, na? So I am doing some very, very difficult question. So easy questions will be automatically done because I am covering a lot of fundamentals along with these questions. Question number 3. Question number 3. Yeah. Which of the following affects the barreling of a cylindrical billet during the open forging? If you see the barreling, you know what is the barreling? Suppose this is your die, and this is the work you are supposed to forge. This is the work you are supposed to forge. But after forging, the work will become like this, like dumbbell. This defect is called barreling. This defect is called barreling. And a barreling is a common defect. Barreling is a common defect. So can you tell me which options are correct? A, B, C, D. Only one option is correct here. Can you guess which option is correct here? Just guess which option is correct. Or if there is any confusion, you can let me know. Barreling. Yeah, Manoj Kambhavat. Okay, only one response came. Okay. Oh, very good. Rohit D. Saurabh Pattani B. A, B, D answers came. Somebody can tell C so that all the options are correct. Somebody can tell C so that all options are correct. All right. Let us discuss Let us discuss. Now, if the temperature of billet is high, you know, copyright claim, see. Whose copyright claim you are doing? Huh? Your own copyright or my copyright? Okay, very good. All the options are correct now. Copyright claim has proven. Okay. Now, these 13 questions, the way I have designed, said most of the important fundamentals are covered. So take it seriously. I will discuss side things related to the questions. So, lot of things will be prepared just by this discussion. Why we form the material at elevated temperature? Why we form the material at elevated temperature? Because if you see the stress strain diagram, at room temperature, it is like this. It is like this. Suppose if I increase the temperature in most of the materials, diagram keep on shifting in the downward direction. Like this. 300 degrees centigrade, 600 degrees centigrade. But if there is an impurity of chromium and all that, there will be different issue. I will not discuss here. It will be too much because I am discussing questions. So diagram keep on shifting in the downward direction. In other words, sigma naught or mean flow stress keeps on decreasing by increasing the temperature. By increasing the temperature, mean flow stress keeps on decreasing. So when you are forging at a high temperature, because mean flow stresses are less, so the central portion will deform more. And the barreling effect will be more. Higher the temperature, lower will be the mean flow stresses, so barreling effect will be more. Yeah, fundamentals and theoretical. Without material science, you cannot crack any exam. You know how? After that, you have to face interview. Primarily in the interview, they focus on material science. ISRO, DRDO, BARC, any IIT's MTech interview for mechanical, without material science, you cannot get away with it. And for most of the private colleges, they don't study material science. They mug up the subject. They don't study. It's an unfortunate part. Anyway, so temperature definitely increases the barreling effect. Now, coefficient of friction. Now, these are the die, upper die and lower die. If the coefficient of friction, yeah, good evening, Rahul. Joined late, little bit, huh? No problem, parvaledu, I think. Huh? Between the die and the material, if the coefficient of friction is high, between the die and the material, if the coefficient of friction is high, then this portion of material will not flow much because of high coefficient of friction. So the material that is in contact with the die will not flow because of high coefficient of friction. So higher the value of mu will increase the barreling effect. So second option is also correct. So the second option is also correct. Kalyan Dwarapudi, I think you are from Telugu belt, you know. Good. Welcome to the English channel. we will speak only English now, no Hindi. Now, third is a very controversial point, type of billet material. Now, Type of billet material means whether it's a ductile material or brittle material. On that property, barreling effect will not be depending upon. But certainly, if you are saying type of material in terms of mean flow stresses, definitely it will affect. But degree of brittleness, degree of ductility, it will not depend. Doesn't mean here there is a misconception. There is a misconception that if the material is ductile, their sigma F will be low. It's a misconception. In the detailed discussion, I think crash course also I have discussed a little bit about that. So it will not depend upon the type of material like ductile and brittle. But definitely it will depend upon mean flow stresses. So that's the reason I will not choose this option. Okay, now because there is no clarity. If they say type of brittle material, ductile material, certainly it is not an option. So I will put A. Okay, now very good, very good. There are some questions here. See, Kalyan, every year we get approximately 18 marks from production. 18 marks. Okay, na? Sometime, they say 16 marks in production. You know why? Some of the question they take to strength of materials. But always, every year, there are 18 marks question. See, Rahul, if you are free, join the regular batch. If you are working somewhere, join the weekend batch. But tomorrow onwards, I will be teaching you in regular batch, 7 to 11:30. Okay. This is the next question. This is the next question. Very good, very good. This is the next question. Do along with me. I have very, very carefully chosen these questions. Okay. A billet of 60 millimeter long on 20 millimeter diameter. One more thing you should do in gate, in specifically production, wherever possible, based on the given data, please construct the diagram. Write the data on the diagram itself. Write the data on the diagram itself. Then just by looking at the diagram, answer will be easy. Because it's most of the students, those who will be watching later on, they are English speaking. So I would like to tell you here very, very important thing. In GATE exam, you will appear in the exam after 15-16 days. You should be attentive. Every year I have seen that out of 65, 2-3 questions will be such that you don't have to even solve it. Just by looking at the option, you will be able to hit the answer. 2-3 questions. If you get into the solution, unnecessary 10 to 15 minutes will be wasted. Time is short. So please be attentive. All right, next question, and I am going to construct it. So based on the given data, we will see how to solve this question. Okay. A billet 60 millimeter long and 20 millimeter diameter and 20 millimeter diameter is to be extruded in a direct extrusion process with extrusion ratio 4. Direct extrusion means you are applying pressure in this direction and extruded part comes out in this direction. And extrusion ratio, what is that? Initial area over final area is called extrusion ratio, and it is given as 4. The extruded has the round cross section, the diangle, half angle. Okay, clearly mentioned there, half angle is 90 degree. Alpha is equals to 90 degree. The work metal has a strength coefficient of 396 MPa and strain hardening exponent 0.15. This is the flow curve equation of the work material, flow curve equation of the work material. Use the Johnson formula with A is equals to 0.8, B is equals to 1.4. B is equals to 1.4. Estimate the extrusion strain. The pressure applied to the end of the billet as the ram moves forward. You have to find out what is the extrusion pressure to move the billet in the forward direction. Shabash. But anyway, this is the data. Write all the data on the diagram. Okay. So sigma D is nothing but sigma naught A plus B ln R. Extrusion ratio is given to you. And because there is a flow curve equation, the sigma naught will be the mean flow stress is equals to K epsilon raised to power n over n plus 1. And we have to find out the true strain. Extrusion ratio is given to you. So initial area pi by 420 square divided by AF is equals to 4. So you can find out AF pi by 4 DF square. So you will get DF also. Okay. Now there is one funda. That we use in metal forming, especially whenever we have to find out the mean flow stress. We calculate true strain. In the direction of applied load, the direction in which the deformation is taking place. So epsilon is nothing but ln LF by Li. Constancy of volume AI Li is equals to AF LF, constancy of volume. So LF by Li is nothing but AI by AF, and it is 4. You can put it here, you will get epsilon. You are correct. Rohit, you are correct. In gate, I have seen many times that some extra data is given that will not be useful anywhere in the calculation. Data that will not be used anywhere in the calculation. Mostly I have seen these things in forming and casting. So don't get confused that, oh, this data is also given, so it must be used somewhere. No, not required. So now calculate epsilon, put it here, you will get sigma naught. Put the sigma naught here, find out sigma D. Yes, most of the data may not be used anywhere. Yeah, both of you, Manoj Kumar Kumbhavat and Rohit Kumar. 991.16 MPa. So that is the answer. In casting, many times what I have seen that 2-3 additional data is given that is not used anywhere in the calculation. So you have to be very careful. You have to be very careful in gate exam. So 2 things I have told you while attempting gate questions in actual exam on 4th. Your head should be cool. Before embarking the solution, see the option. Quite possible that you may not have to solve. When I was doing PYQ, 7.5 hours I taught you. I think some of you may not be there because it was in English. So I told you, see, this particular problem, you don't have to even solve it. This is the answer. Okay, na? So please be careful. And the second thing that I told you is, especially in the forming and casting, lot of additional data is given that is not required anywhere. So please remember these things. Okay. Okay, next question. Next question. Next question. A 10 millimeter diameter annealed steel wire is drawn through a die. It's a wire drawing operation now. It's a wire drawing operation. So 10 millimeter diameter wire is drawn through a die at a speed of 0.5 meters per second to reduce the diameter by 20%. So when the diameter is reduced to 20%, means the final diameter is 80% of this diameter. So 80% of 10 is 8 mm. Final diameter is 8 mm. The yield stress of the material is 800 MPa. So here there is a catch. I will tell you. In GATE exam, when you were present, I think you know Hindi also, because some students said, sir, please speak English and all that. I was speaking English there, PYQ. All our faculties, yeah, they put a lot of effort there, actually, PYQs. Because not just giving you the answer, giving you the side thing, so that you can handle the new questions also. All the faculties of our team Dhona, they really put a lot of effort. I will tell you, first time I woke up till 3 o'clock in the night. I sleep at 9 o'clock, 9:30. But first time I woke up and taken class, such a long class. So I will tell you one thing here. If the yield strength is given to you in question, it means examiner is telling you that material is elastic plastic. So yield stress is nothing but sigma naught. And if the work hardening exponent is given to you, sigma naught is K epsilon raised to power n over n plus 1. Point number 3. If Ys and Uts are given to you, it means it's a linear work hardening. Sigma naught will be Ys plus Uts divided by 2. Please don't forget this particular point. Please don't forget this particular point. Achha, okay, all right. Okay, all right. Once again, when yield strength is given, take it that as sigma naught. When Ys and Uts are given, take average. When flow curve equation is given, K epsilon raised to power n over n plus 1. So anyway, the ideal stress and power required for drawing, ignoring the friction and the redundant work. Ignoring friction means the problem becomes very easy. Sigma D is nothing but sigma naught ln AI by AF. Because if there is a friction, then which formula we will be using? Sigma D is equals to sigma naught 1 plus B by B 1 minus AF by AI raised to power B. This formula I will be using. But if it is a frictionless case, I will be using directly this formula. Okay, na? And it's a 357 MPa. 357 MPa. Stress is 357 MPa. And power, no, I think our boy made a mistake. Manoj Kumar, we have made a mistake. Power, see, what mistake you are doing? Extrusion, we are pushing the material from the back. In a wire drawing, we are pulling the material from the front. So to calculate the force, sigma D, we have to multiply it by that area. The area at which I am pulling or pushing. It is AF, not AI. I think you must have multiplied with AI. So AF. So that will become force. Power will be force into velocity. Power will be force into velocity. Velocity is given to you. AF is equals to pi by 4 d square. So can you tell me now what is the power? I think you know, if you are slightly inattentive, you will get into wrong answer. Can you give me the answer quickly? Some of you are champions. Yeah, now answers are coming correct. Huh? Yeah, 8.97, correct. Manoj Kumar Kumbhavat. 8.97 kilowatt. This is the correct answer. 8.97 kilowatt. Saurav Pattani, I think your answer. Rohit Kumar, correct. Now Manoj Kumar answer correct. See, once again, these type of problems keep on appearing in the gate with a different angle. If it is an extrusion, we are pushing. So for the calculation of force, I will multiply it by initial area. In wire drawing, I am pulling the material from the front. So I will be applying by final area. Please do not do any mistake. Have your head cool. That's what some of you made mistake before. Is that okay with everybody? That is the answer. That is the answer. Correct, na? Okay, okay. Easy, na? Shall we move forward now? Easy, na? Shall we move forward? Once again, these are 13 questions for English channel. For our regular, that we are calling Super 30. So on 17th, those problems will be totally different problems. Okay. So collecting this on 28 problems from my side. I personally made all these problems. Okay. So, acha, okay, drawing ratio say you multiplied with the drawing ratio. No problem, no problem. Yeah. This MCQ match the following. Please read the question. Please read the question. Okay. Match the requirement from group 1 with the suitable casting process from group 2. Okay. Now, good surface finish. Which casting will produce good surface finish? What is the criteria of good surface finish? Certainly sand casting cannot produce good surface finish. Certainly sand casting cannot produce good surface finish. No matter how big champion you are, do this by the process of elimination. Do this by the process of elimination. Ornaments are always produced by slush casting. You know what is slush casting? This is the die. Okay, na die. Suppose the bottle is a die. Put the liquid metal into it and then do it like this. And the remaining material, you take it out. Now die is a split die. You open and you will get thin shell of bottle. It is called slush casting. Put the metal in the die, do like this, and take the liquid metal out. Split it, you will get casted part. Jewelries, gold jewelries are manufactured by slush casting. All the different types of gold jewelries are hollow. You know, you take your mother or your sister's jewelry, it is hollow. It is hollow because of two reasons. Reason number one, gold density is very high. gold density is, I will tell you the first reason. If the gold jewelry is not hollow, it will have a lot of weight. So cost will also increase. So whatever jewelry you are getting in 30,000, it will be available in 3 lakhs. Who will purchase? But I'll tell you, South India, there are many people who will purchase. Because even men, ladies, everybody wear a lot of gold, at least 3-4 kg gold. Let us say some people purchase that jewelry, but its density is very high. It will be so heavy that if you wear a necklace, you will boom like this. It will be heavy. So that is the reason gold jewelry is always made hollow by stress casting. Oh, there are some questions, I think. Yeah, now this question actually, our aesthetic engineer, his answer is not aesthetic. Okay, all right. So D:1. So this option cannot be. I am purposefully spending time so that things goes to your mind. Do by the process of elimination. Now, heavy casting. Heavy casting cannot be made unless and until it's a sand casting. Because after casting, you have to break the sand mold and get the product out. Heavy castings are made only by sand. So C has to be 4. D cannot be. Now, see, that is the way we eliminate. Now, good surface finish we will get only by the pressure die casting. Only by the pressure die casting. Pressure die casting means we are injecting the liquid metal into the mold cavity, and each and every detail of the die will be covered by the liquid metal. There is one more thing. Generally, in the injection molding, dies are made up of metal. Please hear very carefully. Yeah, some of you are really. I am not joking. If you go to market, I am in Hyderabad, Chennai, Bangalore. If you go there, people wear a lot of jewelry. North India, chinna, small thing. Here, heavy necklace, heavy thing. Even the men wear. So if you want to see gold, come to South India. If you want to see artificial gold, go to North India. Okay. Hear this point very carefully. If the mold is made up of metal, and when the liquid metal comes in contact with the mold, when this is a metal, and when liquid metal comes in contact with the mold, because of rapid solidification, you will get very fine grained structure at the surface. Fine grained structure. It will not only improve the strength of the surface, but also improves the surface finish. Okay, we were also poor, till 2000. We were also from average family from UP, below average family. Okay, we were not having any money, but I worked hard. Okay, I was IAS officer for 1.5 years, but still, I never did any illegal things in my life. So, once again, I will repeat this point. If the mold is a metal, when the liquid metal comes in contact, there will be faster cooling rate. So that will faster cooling rate will produce fine grained structure, and fine grained structures are strong. So you will get strength as well as good finish. So good surface finish we will get in pressure die casting, and expandable mode in investment casting. Investment casting, like epoxy, not epoxy, that like some kind of plastics, you can use it. Wax also is expandable, but wax we have to remove it by firing from the mold cavity. investment casting. So answer is A. Most of you hit it correctly. But my job here is not to give you the just answer, but to discuss. Okay, na? Very good, very good. I think all of you are doing well. So I will call this series as Super 13. 13. Okay, na? I have taken 13 questions. This is again this thing related to the defects. This thing is related to the defects. See, I have shown you in PYQ. I have shown you in PYQ that especially in Misran and blowholes, many questions appear. I shown you in PYQ. At least 3 questions we did in last 10 years, where how the blowhole appears, different reasons. I have discussed the reasons also, but here also again we will do. So blowholes appears because of primarily 2 reasons. Other reasons may be there. Reason number 1, again I'm discussing. See, you know, I'm speaking from Hyderabad, and today is Sankranti. People are on their rooftop with their DJ. I don't know whether you are hearing that music or not, because I'm hearing the mic. All my around the DJ, and they are wearing, flying kite. So if there is some disturbance, I'm sorry for that. I cannot do anything because today is a South India big festival. There's a DJ in just side to my house. Blowholes are because of 2 reasons. Collapsibility. During the solid contraction, if the work drags the mold wall, metal is weak. So if there is a drag, there will be cracks on the surface, called blowholes. And second reason why where the blowholes will appear, during chilling. What is the chilling? Suppose this is the mold cavity. And all around that we have kept chills. So can you just confirm whether this disturbance is coming to your sometime? People are shouting, na? Coming to you or no? Of course, it should not come because it's a mic, but I can hear all this. Anyway, just confirm me whether you are able to hear that disturbance. Okay. So when the liquid metal comes in contact with the chills, a rapidly moving solidification front moves towards center. Okay? No, very good. I'm happy. So when the rapidly moving solidification front moves towards center, each solidification front will have some stress associated with it. So when the oppositely moving solidification front meets at the center, their residual stress will multiply by 2. And if the combined residual stress exceeds the fracture limit, there will be tearing at the center. And this is also called hot tear. Please remember, in PYQ, I have explained to you 3 questions in last 10 years, same match the following. That is the reason purposefully I have kept this question here. So C has to be 2. So B and D cannot be the answer. Do it by the process of elimination. Okay, very good. Misran, improper. 3 left, na? Misran is improper heating of metal. When the pouring temperature of the material is low, fluidity will be less. So what will happen when we are pouring the liquid metal here? Casting will not be full. There will be defects like misrun and cold shut. So A:3. Oh, this is the only A:3. This is the only option. But anyway, we will see. B:4. Shift, mold and core making. You know when the shift will happen? When cope and drags are not matched properly, there is a misalignment. Cope and drag. So that condition will appear only here. And scab is sand expansion. Swell, scab, and rat tail. I will speak about scab. One defect is like this. Another defect is like this. And another defect, suppose there is a thin section. This is a rat tail, scab, and swell. All these three defects appears due to hydrostatic pressure of the liquid metal. Hydrostatic pressure of liquid metal. Hydrostatic pressure of the liquid metal. So suppose in any region there is an improper ramming of sand, and if the sand is displaced like this, it is called swell. But in the roof, if the sand is displayed, primarily hydrostatic pressure, and the region where there is an improper ramming, scab. And in this thin section, when these things are appearing, it is called a rat tail. So here answer will be A. Good, na? Yeah. So very good. We are ready to go for next question. We are ready to go for next question. 7 questions are over. We are ready to go for 8th question. This is the 8th question. One more thing I told you that if you get these type of questions, make fit diagram. H7, G7. This is the hole because it's H. A, B, C, D, E, F, G, H. G type of shaft will be here. This is H7, G7. So what type of fit it is? It's a clearance fit, correct, na? So it's a clearance fit. Clearance fit. This option cannot be correct because first fit is a clearance fit. Now go for H7, R6. It's a hole H. Now see shaft H, I, J, K, L, M, N, O, P, Q, R. R will be here. R will be very far. It's a basic size. H will be here. H, I, J, K, L, M, N, O, P, Q, R. R is there, na? So shaft is much bigger than hole. So it's a interference fit. Now answer should come, na? Interference fit. Clearance fit, interference fit. So this transition fit cannot be the answer. Okay, na? Very good. Manoj Kumar Kumbhavat. H7, N6, it will be transition. H7, N6. I, J, K, L, M, N. N will be somewhere here. H is here. So it's a transition fit. So just based on the clearance and the interference fit, we can conclude that it is a D. Very good, very good, very good. So it's easy, na? I told you that in GATE many question appears based on the type of fit. Don't give the answer blindly. Make the fit diagram before hitting the answer. These are the fit diagrams. Do not give the answer directly. Make the fit diagram and then give the answer. Okay, everybody's okay? Let us move to the next question. It's a very good question. Next question, please read the question. Thank you very much. Okay. First of all, what are the line standards and what are the end standards? What are the line standards? What are the end standards? Line standards are kept on a simply supported beam because whenever there is a beam, there will always be some deflection. There will always be some deflection. So in the line standards, just above the support, we are measuring the distance between the two lines. One line is drawn just above the support and we are measuring the distance between the two lines. These line standards are quick. These line standards are quick. But line standards, there is a problem. There is a problem of parallelism. There is a problem of parallelism. You know what is the parallelism? Suppose there are two lines. If you continuously keep on watching those lines, sometimes it appears there are three lines, one line, two line. Like there is one drunkard. Suppose he drinks some around 1 or 2 peg. Then one person appears to be 2, 3, 1. So he's confused, na? Same thing when the line is very fine. You will have, oh, there are two lines, one line. This problem is called even when you are not drunk. Don't think that every drunkard person will do the inspection. Then one is getting confused. It's a one line, two line, or three line. So this is called parallelism. Okay, na? Now, what is end standard? End standard, again there is a beam and it is simply supported in such a way that these surfaces are flat. So with the help of hemispherical ended micrometer, I can measure the distance between the two ends. Like I will give you some example. All the measurements of slip gauges, fall in end standard, because when we are building up any dimension using slip gauge, we are worried about this distance only, na? So all the slip gauge measurements are end standards. Okay, very good. But clearance fit, interference fit, and transition fit, these are international standards. You know what are the international standards? There are 25 different types of fundamental deviation and 18 different types of fundamental tolerances. 18 different types of fundamental tolerances. With the combination of fundamental tolerance and fundamental deviation, I will make any one of these three fits. So all these 25 and 18, there are international standards. Okay, so through this question I wanted to teach you what are the line standards and what are the end standards. Okay na? Okay, Manoj Kumar Kumbhavat, if you crack gate, I will be the first person to be very happy with you after your parents. Okay na? A teacher becomes very happy when the students are growing and excelling. Okay, so I will be very happy. Let me know once you get the final result. Work hard and I hope you will get it. Okay na? Yeah, it's a MSQ. More than one option is correct. More than one option is correct. Interchangeability is R, not applicable for which of the following statements? So there are two statements where interchangeability will not be affected. Limits the mass production. No. Interchangeability, you know what is the interchangeability? In short, I will tell you what is interchangeability. Now I want answer for this 10th question. Hole and shaft I will make separately. Let us say hole I will make it in Hyderabad, shaft I will make it in Bangalore, and assembly I will do at third place, and it will be done very perfectly. It's interchangeability. Interchangeability will happen when the process capabilities are equal to the desired tolerance. When the process capabilities are equal to the desired tolerance, and it is always done for mass production and mass usage. So limits the mass production. No, that statement is not applicable. It doesn't limit the mass production. It is meant for mass production. Restrict the assembly of mating parts. No, this statement is also not correct. In fact, it doesn't restrict because there is some tolerance. Na? Within the tolerance, assembly can be made. Doesn't mean that the shaft has to be 25.023 millimeter. No, there is a range. When in that range shaft comes, I will be able to make the assembly. So restrict the assembly to the mating part, that is not correct. Now improves the production rate, yeah, that is correct. So is not, na, that's applicable. These two are not applicable and these are applicable. Improves the production rate. You know why? How exactly it improves the production rate? A hole and shaft I will make at a place where men and materials are cheap. So let us say I will make hole in Patna where labor is cheap. So by that way I can increase the production rate. Produce the parts within the prescribed limit of sizes. Yeah, by selective assembly I will break the process capability range into the desired tolerance. So answer will be A and B. So A and B statements are not applicable for interchangeability. That was the 10th question. It was little difficult theoretical question, but anyway, all of you have to learn it. Reason I am discussing some difficult question is that you becomes habituated with it. Okay. All right. 10th question. Question number 11. See, this question is a PYQ. This is the PYQ question. And in the PYQ, I have given very big explanation for that. Acha, okay. Option A confused. Okay, again repeat. I will repeat again. What is the question? What is the question? Interchangeability is not applicable. Question is asked in the opposite way, not applicable. Limits the mass production. Suppose I want to go for batch production, not for mass production. Interchangeability is not meant for that. Interchangeability is meant for mass production. So it's na limits the mass production it is not meant for interchangeability. If it says are applicable, okay, then why we go for interchangeability? There are three requirements. There are three requirements of interchangeability. Of course, there is a full syllabus of metrology. First requirement is in mass production, desired tolerance range is getting squeezed up, but the process capability ranges are large. Now, how to make assembly? I'm always thinking in the mass production, not the unit production and batch production. Unit production, I always make the component make to suit. But in the mass production, it is always a tolerance. So when we want to limit the mass production, it is not interchangeability. It is not for batch and unit production. Anyway, if there is a slight confusion, don't too much focus on certain things. Once again, I will request all of you, if there is a major confusion, of course our team Drona is there in the Telegram channel, you contact us. But if the problem persists, you forget about it, because it is not good to spend too much time on the problem that bothering you, especially this time. If it is 1 year back, you could have bothered us, and we could have bothered you, but not this time. This time only 16 days, so I don't want to basically waste your time. This is the PYQ problem. This is the PYQ problem, and I will not solve the complete problem, because in PYQ and wherever I teach crash course, everywhere I have discussed this problem. But because we are on the border of GATE exam, so I will discuss some fundamentals, but I will not. If you want to see the solution, I have given in crash course, I have given in PYQ, everywhere I have given. Okay, na? Material science and metrology. Okay, crash course, you can just again watch crash course then. Okay, so once again, 2 minutes you look at the board. 2 minutes you look at the board. This fundamental, I want to cover it again for the English speaking students, and it is very, very important for GATE. If the processes are like wire drawing, or when the tensile stresses are applied on the material, the diagram will be like this. Tensile stresses are applied, the diagram will be like this. And when the compressive stresses are applied, diagram will be like this. Diagram will be like this. Okay? Please be careful. Some of you might have attended my crash course, Abhyas, PYQ, but here again, it's worth repeating. This type of diagram will appear, let us say, in forging, rolling. This type of diagram will appear in the wire drawing. Okay, na? So let us say you reached up to this point and unloaded it. And unloaded it. These two lines will be parallel. And if it is a forging rolling, suppose you have loaded up to this point, and if you unload, these two lines will be parallel. Now, this strain and this strain is called elastic recovery. Elastic recovery. Now, what you should do in exam, what you should do, flow curve equation will be given to you. Flow curve equation will be given to you. Epsilon, we calculate the direction in which the load is applied. If it is a forging, epsilon will be ln hi by hf. And if it is a wire drawing, epsilon will be ln LF by Li. Now, let us say at this point you calculate sigma f. This point you calculate sigma f, just put in this formula, you will get sigma f. K is known, N is known, epsilon is known, okay? Now, when you remove the load, if it is a forging operation, the moment you remove the load, the blank is going to expand. And if it is a wire drawing operation, the moment you remove the load, it is going to contract. This is going to contract. This is going to expand. So now, what you should do, in this triangle, apply Hooke's law. Apply Hooke's law. Same thing for here. In this triangle, apply Hooke's law. But what is the Hooke's law? Hooke's law is stress divided by strain is nothing but Young's modulus. Here there is a catch. By guess, some of you are getting the answer in that range, but you are doing a very critical mistake. In Hooke's law, this is the engineering stress. This is the engineering stress, and this is the engineering strain. Correct, na? But by the formula, you have got true stress. You have got true stress. So first of all, this true stress you convert into engineering stress, sigma f is equals to sigma naught E plus 1. Convert into engineering stress, then you put in the formula. Most of you, what you are doing, by sigma f, whatever stress is coming, putting that into the Hooke's law. Answer will be wrong, but by fortunate, whatever range that is given by gate, it is fitting in that range. But suppose it is a NAT and range is not given, you will be in the problem, na? Hooke's law deals with engineering stresses, and plastic region stresses are calculated based on the flow curve equation. That is true stress. So please be careful. So this solution you will find everywhere, because this problem I take everywhere for the new students, crash course, PYQ, everywhere. So from there you can get the solution. I will not solve the problem here, okay na? Yeah, 95.17, you have done it. I think you were present in our other batches, okay na? But anyway, Patani. So I will not get into the detail, but it's a very, very good PYQ. I will directly get into the next problem. This is another important PYQ. Only 2 PYQ I have taken. 13th problem is different. Last problem is different. You read the problem. You will find many such problems in GATE exam. Don't be in rush. Don't be in rush. So the question is, there is a pin, and over the pin there is a electroplating. There is a electroplating, okay na? And this is 25 plus 0.01 plus 0.02, and this is 30 plus minus 2 microns, meaning 0.03 plus minus 0.002. or 0.03 plus minus 0.002. See, many such type of problems will appear in GATE. Procedure to solve such problem is exactly same. Step number one, you convert everything into equally bilateral. Convert everything into equally bilateral. So 25, this is 0.01, and this is 0.02. So here, this I want to convert equally bilateral. So this will be 0.015. So 25.015 plus minus 0.005. Convert step number 1. Convert everything into equally bilateral, and this overall dimension is a sink. D is a sink, meaning add the basic size together, add all the tolerances together, and you are correct. Answer will be D only. But I'm cautioning you, the English speaking students, I'm cautioning you that such type of problems will come with a different twist and turn. If you apply shortcut, you will be in the problem. So step number 1, convert everything into equally bilateral, and to calculate D, add all basic sizes, add all tolerances, that will be D, and by that you will get the answer. Then if you calculate the tolerances and basic size of D, getting the answer is very easy. So these two problems I have touched because I don't want to get you into any problem. Last problem is a very beautiful problem, and it's a new problem. It's a new problem. Let us see who can hit it. Last problem is a very easy, very good problem, and it's a new problem. Let us see if anybody can hit. Let us see if anybody can hit. It is a very beautiful problem. In a single pass rolling operation, a 200 millimeter wide plate. So rolling operation, I will make the diagram here. wide millimeter plate. So 200 wide millimeter plate with a thickness of 18 mm. Thickness of 18 mm is passed with a speed of 14 meters per minute. Between the set of rollers and reduced to 15 millimeter and reduced to 15 millimeters. I am writing the data. If the roller radius is 240 millimeter, radius is 240 millimeter, it's a really different question. I have made it. Rotation speed is 10 rpm. 10 rpm. And forward slip is 0.082. So here is the neutral plane. Neutral plane. So forward slip will be here. Forward slip is 0.082. The percentage change in the width of the material after rolling. Percentage change in the width of material after rolling. Let us say this is the W1 and W2. Question is asking W2 minus W1 divided by W1 into 100. What is this answer? W1 minus W2 into 100. Question is asking what is the answer? So anything from your side? What is this forward slip? Forward slip will be V2 minus VR divided by VR, and it is equal to 0.082. Very good. Rohit, I'm telling you, I'm looking you from since your crash course. I think you will crack with very good rank, but don't get proud actually, okay na? Have a cool head, do some bhajan. I'm hoping that you will get top 100 rank if you do it right. I'm seeing you from crash course. At least those who are brilliant, I can remember their name. Okay. So we are 2 pi r n, because this is meters per minute divided by 100,000 meters per minute, because millimeter na, divided by 1000, you will get meters per minute. So 2 pi r is 240, n is 10 rpm divided by 1000. So roll velocity comes out to be 15.08 meters per minute. So we know roll velocity and we know forward slip. We know roll velocity and we know forward slip. Calculate V2. Can you tell me what is V2? Can you tell me what is V2 now? Can you tell me what is V2? Actually, some of you are getting the final answer. Eh? This V2 for me, it's 16.32 meters per minute. 16.32 meters per minute. Mind cool. How to do mind cool? Get up in the morning. Don't think anything bad about others. Respect parents and elders. And whatever religion you follow, do some kind of spiritual activity half an hour in the morning. That is the only way to make the mind cool. Some people say do whatever you want to do. By that way, you will never be cool. Okay, now, all right. So V2 is this. Now, what you should do? Continuity equation. Continuity equation. A1 V1 is equals to A2 V2. A1 V1 is equals to A2 V2 is the continuity equation. So can I say H1 W1 V1 is equals to H2 W2 V2. H1 is 18, W1 is 200 into V1 is 14 meters per minute, H2 is 15, W2 we have to find out, and V2 we have calculated 16.32. By that you will get W2. By that you will get W2. And W2 is 205.88. 205.88 millimeter. So if you put, you got W2, you know W1, put everything here to find out the percentage change in the width, and it is a 2.9%. Yeah, you are correct. That is the answer. 2.9%, that is the answer. Yeah, for Rahul, for PhD, somehow you try to get into IIT for MTech program, and if you are already MTech, you just have to qualify, because whatever scholarship you get in PhD, that is linked to GATE score. There is no, so if you are already PhD, if you are already MTech, then GATE score is immaterial, you just have to qualify. But the admission in PhD depends upon what reputation you have with the guide under whom you want to do PhD. Okay, now very good, very good. So there's the answer. So in this English, I have done 13 very, very beautiful questions, and this is the schedule for revision through questions. And that's it for English thing. Again on 17th, I will be bringing myself and my colleague Aditya Palji. We will be bringing very good 30 questions on production and materials. Alternatively, we will be teaching. It will be different from this Abhyas. It will be totally different questions. And those who are joined with me online today, I can remember some of the names even since the crash course. And not only them, I wish to all of you that you get very good rank. Please don't study anything new now. Only 20 days. Don't study anything new. So you practice questions. We are also bringing one Maha revision course for you. One will be live and another will be 3 days before gate. Just be in the Rajai and look at what formulas revision we are doing. So this Maha revision also we are bringing. But once again, don't study anything new. And if you get into any confusion related to any problem, our team Drona is there to help you out. Just be in touch with the Telegram channel. But if the problem persists, I recommend you at this moment, don't keep on moving on the same problem again and again. So I wish you all the best. But after getting rank, please do not forget us. Thank you very much. Your personal problem you can write in the Telegram channel. Thank you very much. Thank you all.